Hi everybody. In this lesson we want to look at how we graph quadratic functions that are given in general form, something that looks like this. And this is the second part. And in part one we looked at how to graph functions like this by completing the square, and we looked in particular where the leading coefficient was 1. So here in this lesson we want to see how to graph ones where the leading coefficient is not 1. So remember, when we complete the square, the leading coefficient has to be 1. And when we were solving quadratic equations like 2x squared minus 12x plus 10 equals 0, the way that we made the leading coefficient 1 was we divided both sides by 2 in this case. And then I would complete the square on what was left. So I had x squared minus 6x plus 5 equals 0, and then I'd push the 5 on the other side. And then I'd add 9 to complete the square, and I'd add 9 to the other side, and so on. Okay? So, and then that would give me x minus 3 squared is equal to 4, and I could extract the square roots. Well, when I go to graph f of x equals 2x squared minus 12x plus 10, by rewriting this in vertex form by completing the square, obviously I can't just make the 2 completely go away, because this is going to make the graph be skinnier. So what I need to do, the way that I'm going to do this a little bit differently, is, remember, I have to keep everything on one side. So I'm going to take the first 2 terms and factor 2 out of just those x terms. So that leaves me 2 times x squared minus 6x, and I'm going to leave a little space to complete the square. And notice I did not factor the 2 out of the 10. I'm just going to push the 10 off over here. So notice at this stage I still have 2x squared minus 12x plus 10. This is exactly what I started with. But now, because the 2's factored out of these x terms, I can complete the square on this part. So I'll take half of the negative 6, half of negative 6, negative 3, and square that. So I'll add 9. Okay. Now here's where it gets just a little bit tricky. When I add 9 to complete the square, over here I could just add 9 to the other side. Well, here I have to keep it on this side, and also over here I notice that there's a 2 that's multiplying that 9, right? So even though I added 9 to complete the square, I'm really adding 18 to this side of the equation. So I have to come over here and I have to subtract 18 to compensate. So what you should be able to do at every stage of this process is be able to multiply it out and have it equal what you started with. So let's just check. I got 2x squared, that's right here. I got a negative 12x, that's right here. I got a plus 18 and a minus 18, so that cancels out. And then I got my plus 10 is right there. Okay? So now I can simply write f of x is 2, and then this is a perfect x minus 3 squared, and 10 minus 18 is a negative 8, and there I have it in my vertex form. I know that this is going to take the graph of x squared and move it 3 to the right, so my vertex is going to be 3, and then down 8, so my vertex is 3, negative 8, and I know that this 2 is going to make it look skinny. So let's go over here 3 and go down 8. There's 2, 4, 6, 8. And instead of going over 1, up 1, I'm going to go over 1, up 2, because that stretches these the normal x squared graph by a factor of 2. Instead of going over 2, up 4, I'll stretch that by going up 8. I'll double the 4 to 8. Okay? So that gives me a parabola that looks something like this. You can see it's a little skinnier than our normal x squared graph. Okay? And if you use your imagination, you can pretend it went through that point, or maybe move that point over like that. Okay, so I know the axis of symmetry. It goes right through the vertex point, so that's going to be x equals 3. And you can see from my from the graph, the x-intercepts are going to be at 1 and at 5. And you can get that also by factoring this. Remember, to find the x-intercept, you set your y value equal to 0. So notice that's the same thing as what I did up here. If I divide both sides by 2, I'll get the x squared minus 6x plus 5 equals 0. And then if I factor that as x minus 5, x minus 1, you can see that x equals 5 and x equals 1 are your x-intercepts. And that's exactly how they should be, so everything is matching up correctly. And the y-intercept is going to be f of 0, not f of x there. Let's plug in 0. And if I plug 0 in, I'm going to get 0 here, I'm going to get 0 there, and I'm going to get 10. And so my y-intercept's at 10, so over here at x equals 0, it's going to be way up here. And you can see that's going up pretty steep, and that'll cross up there at 10. Okay? All right, let's go on and do one more problem like this. Here I'm asked to rewrite f of x equals 1/2 x squared minus 3x plus 2 in this vertex form and sketch its graph. So again, what I'm going to do is I'm going to group just the x terms together, and I'm going to factor that leading coefficient out. So I'm going to take a half out of a half x squared, that'll leave me x squared, and then I have to factor a half out of negative 3. So I think to myself, well, what would I have to multiply a half by in order to get negative 3? And that's going to be a negative 6, right? So half of negative 6x is negative 3x. And then leave a place to complete the square and push your 2 over here on the right. So take half of the negative 6 is negative 3 and square it. So I added 9 here to complete the square on this part, but that half multiplies it. So I really added 9 halves. So I have to come over here and subtract 9 halves in order to compensate. So again, just double check. I've got my half x squared is right there. I got a negative 3x right there. I got half of 9 and then subtract half of 9. So that cancels, and here's your 2. So this function is going to be 1/2 x minus 3 squared. This is a perfect x minus 3 squared. And then I've got 2. That's going to be 4 halves. Let's go ahead and multiply this by 2 over 2. So 4 halves minus 9 halves would be a negative 5 halves. All right, so my vertex is going to go 3 to the right and down 5 halves. And this 1/2 tells me it's going to open up a little fatter, right? So I'll go over 3 and down 2.5. That's about right here. And then instead of going over 1 up 1, which would put you right here, I'd go over 1 up just half of that. And instead of going over 2 up 4, that would be up here somewhere. I'm going to go over 2 up 2, half of 4. So that would put you here. Let's see, 1, 2. I guess that's right here. Let me erase that other mark. And then over on this side, over 2 and up 2. So you can see that this is going to have a little wider parabola. It'll look something like that. Your axis of symmetry is x equals 3. Your x-intercepts, well, how am I going to find those? Well, I'd have to set x or y equal to 0, so I'd get 1/2 x squared minus 3x plus 2 equals 0. I could multiply both sides by 2. I don't know if this will factor. It kind of looks like from the graph that that's not going to cross at a very nice value. So I think what I'll do is I'll just use my quad program on my calculator, and let's plug in here half for A and negative 3 for B and 2 for C. And yeah, sure enough, that's not a very nice number, is it? So I get about 5.236. So we'll just say x equals 5.236. Maybe I'll make those little wavies. Or x is approximately, what was the other one here? 0.764 if I round off to the thousandth. And I'll just say here, by the quadratic program on graphing calculator, Okay, if you don't have that, I have another video where I showed you how to program that into your graphing calculator. All right, so does that seem reasonable? Here's 0.764. Well, yeah, that's pretty close to 3/4, isn't it? And over on this side, it should be a little more than 5. So here's 3, 4, 5, and a little bit more. That would be 5.236. And then to get the y-intercept, I just have to plug in x equals 0, and that's going to very quickly give me my constant term there too. And so this is going to come up, and we'll go through here. Okay. All right, and then of course it'll do the same thing over here because of the symmetry. So my parabola looks something like that, and if I want a more accurate graph, I can always plug it in my graphing calculator. Okay.